Hello, my name is Katherine Zellner, and I'm a member of the Interactive Systems for Healthcare Lab, formed by Drexel University, Children's National Hospital, and Rutgers University. Today, I'll be presenting our research on developing a speech-based model for tracking the progress of activities during extreme action teamwork. Our lab's research is situated within emergency medical teamwork, specifically the area of trauma resuscitation. During trauma resuscitation, a complex team of clinicians, including surgeons, anesthesiologists, nurses, and more, work to stabilize severely injured patients before moving them to further care. During trauma resuscitation, medical delays and errors contribute to nearly half of preventable deaths, meaning there's room for a system to help improve the teamwork in trauma resuscitation. Our team's goal is to develop a system to support awareness of time, delays, and the progress of the team during emergency medical scenarios in hopes that it will reduce errors and delays. To create the system, we need to be able to automatically and unobtrusively monitor activity progression. We hypothesize that speech is a data input that can be used to identify the stage of activity performance, i.e. during, before, or after. In this paper, we developed the model to determine the temporal progression of activities based on speech and within trauma resuscitation. Related work in statistical language modeling explores the use of narrative schemas to represent script knowledge and predict a missing or upcoming event in simple stories about daily activities. We use the concept of narrative schemas and we model stories through them, but our work differs in three ways. First, we're using stories derived from actual conversations during dynamic teamwork. We use speech data to infer this team's status and progression of work rather than describing or generating stories about the work. Lastly, the stories in our data set are often incomplete and composed of choppy, grammatically incorrect sentences, which makes the machine learning model training more challenging. To accomplish this study, we situated the study within the emergency medical domain, and we transcribed 104 audio recordings of actual trauma resuscitations. Using the transcripts, we first studied the nature of speech during 34 clinically relevant activities. 25 of these were assessment activities where the clinical team is evaluating the patient, and 9 of these are control activities when the team is actively trying to control the status of the patient. From this analysis, we identified 11 communicative events across the 3 stages of activity performance: before, during, and after. Here we can see the communicative events that we derived. In the before stage, also known as the activity planning and preparation stage, clinical teams will discuss assessing feasibility or need for an activity. They'll request members to perform an activity. They'll request clarification or more information on an activity. They'll inform the patient about an activity or request them to perform an action. The during stage, or the activity execution stage, clinicians are asking patients questions or requesting patients for them to perform an action. Clinicians are requesting information on the progress of an activity from each other. They are reporting progress of an activity. They are requesting to modify or terminate an ongoing activity. Then the after stage is the evaluation stage, where clinicians are reporting results or outcomes of an activity. They're requesting clarification or more information about a finished activity, and they're assessing results or the outcome of an activity. These communicative events served as building blocks for our narrative schemas, and we developed a narrative schema for each of the 34 clinical events. This is an example of one such schema that was used for assessing the airway. So first we can see that there is a request to perform airway assessment where clinicians discuss, check the airway, is the airway protected, is the airway good? Then they will move to query patients or requesting them to open their mouths with speech lines such as, hey, do you know where you are? Wake up, how are you feeling? Can you give me your name? Open your mouth. Then the after stage will be when they report results of the airway assessment, and a clinician will say, airways are intact. airway is patent. Airways are protected. So by analyzing these speech lines, we can tell what stage of activity progression they are in. We developed the final generalized speech-based model by extracting and aggregating the generalized aspects of those 34 schemas. The speech flow model here illustrates the differences between both assessment and control activities. It starts on the left, showing the progression of assessment activities, and then on the right, you can see the control activities. Assessment here generally is requesting an activity assessment, then interacting or requesting, perform actions, reporting progress, reporting results and activity. But in control, first they assess the feasibility or the need of a control activity, then they request it, report progress, report outcome, and they will repeat these steps until the activity is over. We then evaluated this model by applying it to 17 new transcripts to see if it held true. A researcher read through each speech line and saw if they could apply the model to evaluate when in the speech model they were happening. So for okay, can you check his pupils, was before stage, look at me, don't move, was during, pupils are 2 millimeters reactive, so reporting an outcome and a result, so that's after. In this evaluation, we found that the model reliably recognized an activity stage in 98% of activity-related conversation instances, showing that this model is suitable to be applied to our trauma resuscitation example. Our results have several implications for designing technology to support complex teamwork, and specifically to detect delays during time-critical teamwork. First, the system design should focus on the after stage. We found that it is the most critical role to detect activity completion. Secondly, the majority of speech lines took place in the after stage, and this means that there are fewer in the before and during stages, and we may require other modalities to detect those stages, such as motion or equipment sensors. Lastly, we found that incomplete speech still poses a challenge, as it would be difficult to automatically detect activity progression if we do not have complete sentences. This is a dense and rich paper with a lot more information about every step, but specifically if you would like to learn more about how we apply this model to machine learning applications, there is so much more there that you can read more about in the paper. Thank you so much for listening. I'm really excited to share this research with you all. Feel free to send us any questions through email, and thank you so much.